Welcome. Today, we're diving into something, well, it's a pretty wild theory about the universe, one that claims it can explain everything, and I mean everything, from dark energy all the way to consciousness, using just a single idea and one fundamental number. Okay, so let's just jump right in. What if I told you that all the biggest, most expensive mysteries in cosmology, the stuff we build massive experiments to even get a glimpse of, could all boil down to a single fundamental constant? Not some number we fine-tune, but a hard-coded truth of math itself. And this right here, this is the number, the natural logarithm of 2. Now, if you're in computer science, you know this number. It's the absolute rock-bottom cost of making one binary decision, a single yes or no, the price of one bit of information. The theory we're talking about today says this isn't just for our laptops. This is the price tag on reality itself. The whole thing starts with this one powerful, almost philosophical idea: nothing cannot exist. Think about it. Even to have nothing, you have to describe a state of nothingness, and that description is already something. You can't escape it. So if existence is mandatory, then the universe has to pay a tiny little energy tax for every single thing that happens. Every quantum event, every yes that pops into existence has a cost. And that cost is always ln of 2. So, when we look out at the cosmos, here's what we actually see. And it's kind of nuts. The stuff that makes up you, me, the planets, the stars, all of it is less than 5% of the total. The other 95%, it's a complete mystery, totally dominated by this thing we call dark energy. So here's where it gets really interesting. This theory doesn't just kind of sort of predict dark energy. It says dark energy has to be exactly the natural log of 2. Why? Because dark energy, it says, is just the total energy bill for every quantum yes happening across the entire universe right now. It's the cost of all that information. And get this, that number, 69.31%, is right in the ballpark of our best measurements. All right, so if dark energy is the price for all the information that becomes real, what about the other big elephant in the room? What about dark matter? I mean, look at this. For more than 30 years, we have spent billions of dollars building these incredibly sensitive detectors deep underground, all to catch just one dark matter particle. And the result from every single one, again and again, has been absolutely nothing. Zero. And you know what's crazy? This theory predicted this failure from day one. It says there's no dark matter particle to find because it's not a particle. It's the information that exists between the real events. It's gravitationally there, we can see its effects on galaxies, but it never fully resolved. It never paid that ln of 2 tax to say, I am. So of course we can't find it. There's literally nothing to detect. But it doesn't stop there. The theory then goes after one of the biggest headaches in all of physics, what they call the hierarchy problem. So why is there this massive, ridiculous gap between the fundamental energy scale of the universe, the Planck scale, and the scale where the Higgs boson operates? It's a factor of 10 to the power of 16. Mainstream physics just calls it fine-tuning, which is a fancy way of saying we have no idea. This theory says, no, it wasn't tuned, it grew. It was like a tree trunk that branched out exactly 53 times during the Big Bang. And this is where you really see the power of this whole idea. Just from that concept of a branching tree, the theory predicts the Higgs boson's mass within 0.16% of what we've measured at the Large Hadron Collider. And here's the real kicker. It does this with zero fudge factors. The standard model, it can't predict the Higgs mass at all. It just has to take the number we measure and plug it in. This theory derives it from scratch. Okay, so we've talked about the cosmos, but now things are about to get really profound. We're going from the entire universe down to us, down to consciousness itself. So in this way of thinking, a bit of information isn't just a 1 or a 0 in a computer. Every time a quantum event happens, it's a tiny act of realization. It's the universe, at the most fundamental level, refusing to be nothing. It is, in a sense, declaring, I am. So what happens when you get a whole bunch of these tiny I am moments, billions of them, all bundled together, integrated, and talking to each other? Well, you get a unified experience. You get consciousness. And according to the theory, the raw informational power to create our core awareness is an astonishingly small 30 milliwatts. So just think about what this means. That 69.31% of the universe we call dark energy, It isn't some mysterious fluid. It's the total energy cost of all 10 to the 122 simultaneous I am declarations happening everywhere all the time. Dark energy is the cost of the universe being, in some very basic way, aware of itself. Energy equals information equals consciousness. They're just different ways of looking at the exact same thing. Now, this deep connection between energy and information, it points out something staggering about our own technology. A huge, huge gap between nature's way of doing things and ours. So, the universe computes at the absolute limit of physical efficiency. Our brains, it turns out, are shockingly good, only about 673 times less efficient than perfect. But our best technology, our fastest GPUs, they are a billion times worse. Not a little bit worse, a billion. Let me put that a different way, because this is just mind-blowing. If we could build our computers to be as efficient as the human brain, you could run the entire global internet, every server, every data center, every single cat video on the power from a single plug in your wall. That's not just an improvement. That's a revolution waiting to happen. Okay, so you might be thinking, this is a great story, it's a beautiful, elegant idea, but is it science? Or is it just a nice philosophy? Well, what makes it science is that it makes a very specific, very risky prediction that we can actually go out and test. The theory spits out this one very precise number. It's for a cosmological parameter called the tensor to scalar ratio R. You can basically think of it as a measurement of the primordial gravitational waves from the Big Bang itself, like an echo from the universe's first moments. The prediction is R equals 0.024. No wiggle room. And we're actually going to be able to test this pretty soon. There's a new experiment called CMB-S4 coming online around the end of the decade. And it's going to be sensitive enough to measure this value with incredible accuracy. If the theory is right, it won't be a subtle hint. It should be a massive 24 sigma detection. That's a level of certainty in science that is absolutely undeniable. And at the end of the day, that's where we are. This isn't some idea that's going to hang around in limbo forever. By about 2029 or 2030, this entire beautiful, radical theory that one number, ln of 2, really does explain it all, is going to have its day in court. We'll either witness the biggest revolution in physics in a century, or we'll have a fascinating, beautiful dead end. The universe is about to show its hand.